Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video.
In this video, we're going to talk about how we can simplify some complex fractions. So first of all, what is a complex fraction? It's just a fraction that is a fraction, or has a fraction, in its numerator or denominators, right? So it's kind of going to look a little bit weird. So if we look down into this example, right, it's like we have something divided by something, divided by something, divided by something, right? So it just kind of looks a little bit weird, so we call it a complex fraction. So simplifying one of these, there's actually two different methods, and we'll use both of these methods here, and then here on out you can kind of choose whatever method you like best. But method number one, we're going to simplify the numerator and denominator by writing each as a single fraction. So if we have a sum in our numerator or denominator, so like for example, we would simplify this part first. So once we do that, then we're going to divide by multiplying the numerator by the reciprocal of the denominator. So that's how we'll do number one. And then method number two, we're going to multiply the numerator and the denominator by the least common denominator, or LCD, of every fraction that's in the numerator and denominator, and then we'll simplify from there. Okay, so example number one, we will use method number one. So what we want to do is go ahead and simplify the fractions that we have in the, or basically combine the fractions that we have in the denominator. So if I look here, I know that I could, let's go ahead and keep what we have on top here, so 6 divided by x minus 2. But now we need to multiply, if we think about x minus 2 and x, we need to multiply 1 by x and 3 by x minus 2. So now we would have a denominator of x times x minus 2, and then we would have x plus 3x minus 6 in our numerator, right? So 1 times x gave us our x, and then we distributed that 3 to get 3x minus 6. So now we have x plus 3x, so we could rewrite this now. So we have 6 over x minus 2, and now this is over 4x minus 6 over x times x minus 2. So now we've simplified, or we've combined the fractions in the denominator, so now let's multiply, or basically let's divide by multiplying by the reciprocal. So now we can take 6 over x minus 2, and now we can multiply it by x times x minus 2 over 4x minus 6. Okay, so now look what we have. We have an x minus 2 in the numerator on the right. We have an x minus 2 in the denominator on the left, so those will actually cancel out for us. So we're left with 6x over 4x minus 6. And now we can simplify a little bit right there, because if my denominator is 4x minus 6, we could actually factor out a 2 from that, and we'd get 2x minus 3. And so 6 divided by 2 here, this would become 3 over 1. So now our final answer, we'd say 3x over 2x minus 3. But now remember, we have a couple x values that our denominator can't be. So if we go back and look, we had x minus 2 and x. So we need to say that x cannot be 0 and x cannot be 2. Okay, so that'd be our final answer for number one using method number one. Now for number two, let's use the second method, where we're going to multiply the numerator and denominator by the LCD of every fraction that's in the numerator and denominator, and then we'll simplify. So if we look at our denominators, we have x plus 5, x minus 3, and x plus 5. So our least common denominator would just be those two binomials multiplied together. So x minus 3 times x plus 5. So now once we do that, we can go ahead and multiply. So this is going to be x minus 3 times x plus 5 over x minus 3 times x plus 5. Okay, so now kind of stick with me a little bit here. There's some things that are going to cancel, some things we need to multiply, and I'll try and represent that as best I can. So if we look at our numerator here, we have 3 over x plus 5 times x minus 3 times x plus 5. Well, this x plus 5, sorry about that, this x plus 5 will cancel with that x plus 5, because on the left it's in the denominator and on the right it's in the numerator. So now we're just left with 3 times x minus 3. So this would be 3x 3, and we'll just leave it, we won't multiply here, 3 times x minus 3. Now let's think about our denominator. Well, in our denominator we have two separate fractions, right? It's a sum. So when we look at 2 over x minus 3, what is the part of our least common denominator that the denominator does not have? Well, that would be x plus 5, right? And so we know that this x plus 3 would cancel with this x plus 3. And so 2 times x plus 5 would give us a 2x plus 10. Okay, so now let me take away some of these markings here. All right, and now let's look at the next fraction. So now we have 1 over x plus 5 times x plus 3 times x plus 5. So our x plus 5 here would cancel with that x plus 5. So now we have 1 times x minus 3. So that's just going to be plus x minus 3. Okay? So now we just simplify. So we're going to leave our numerator as 3 times x minus 3. In our denominator, we have a 2x plus x, so 3x, and 10 minus 3, which would be plus 7. Okay, so now let's think about what our answer, we'll move this down just a little bit. Think about what our answer, or what x values we need to eliminate, or what x can't be. So if we go back, we had an x minus 3 and an x plus 5. So we need to say that x cannot be negative 5 and x cannot be 3. Okay, and that'd be our answer for number 2. And that is how you can simplify some complex fractions.